Hi there, welcome back. And this is video 2 in the restoration of this Braun SK 2/2. And impression so far is this thing is really a breeze to work on. I'm really enjoying it, especially since most of the capacitors are ceramics and they've held out very, very well. Can't say quite the same for the resistors. So far I've only swapped one out, but they're all slightly on the high side, still within spec, but a little bit on the high side, which is, well, it's a tendency with these resistors. It just depends on which, the luck of the draw, really. With some of the Grundigs, when you do a check on the resistor values, they're spot on after all these years. In fact, some of them are older than this one. But I got to tell you, this thing is really a breeze because it is so small and so manageable. You don't even need my contraption to put it on, because you can actually rest it on its back just like that, and it rests nicely, nothing gets damaged, so it's worked out very, very well. The other thing I've noticed is the schematic I had for this, which was supposed to be for this model, is actually different to the one they got inside, and it's different to what they've built in here. If you remember, this little thing came with the radio, and it was slightly torn and bent, so I stuck it onto a backing sheet just to keep this thing safe. And when I went and looked at the schematic, it was slightly different to what I had on the screen. So I started again. I scanned this one in, and I've been working on this schematic and finding some of the components are indeed different to the ones that the other schematic gave. Not big differences, but there are some. Some of the capacitors are slightly different. A couple of resistor values over here are different. So now I'm working from the original schematic, and so far it's gone very well. And what have I done? Well, I've done the... You can't really see much because there isn't really much to do except check. So a lot of this is just busy work. I found that one resistor over here, that power resistor. That was quite a bit out, a little bit too far beyond the spec. So I swapped that out. I swapped out 2 of the paper caps over here. Now, so far I've done the checking of the power supply and the audio amplifier. Okay. Now, first things first, I did a check of the power transformer. That worked out well. So the power transformer was good, and the method I use is one that I'll link above. It's just a simple way a safe way of checking that the power transformer is okay. The other test that I did was on the output transformer. I'll also link that above. I've done a video on that separately. The other thing I did was check this capacitor. Now this capacitor is a dual 50 microfarad. I disconnected it and tested it. It seemed to test fine in terms of value. It was something like 48 microfarads. I noticed this is sort of, it looks fairly recent. Not that it's recent at all, but I thought I'd give it a shot at reforming, and it reformed very, very well with the capacitance leakage tester reformer that I built. I'll link that above as well, if you haven't seen that yet. But this thing came out very, very well. It's got about 0.5 ohms of ESR, very low leakage now, and I put it back in. What else have I done? I have not paid much attention to this guy here. Now this is a strange one. Now, like all of you who commented on this particular diode, I too thought it was a bridge rectifier till I looked and found that it was just a diode, a single diode. It's a selenium diode. It's a Siemens, and that's why I mistook it for a bridge rectifier, because I've seen a lot of bridge rectifiers exactly in this format. And I'm not sure how much voltage it's dropping, so I'm not sure that this thing is in good condition or it needs replacing. I'll do a power up and test and see what we need to do with that very soon. So what else have we got here? As I've mentioned before, this thing has got quite a fair amount of space to work on. It's actually quite easy to work on this. Contrary to what you'd expect from seeing the top end, which is crowded as hell, there's actually quite a lot of space down here. And because of the minimalistic type circuit they've used, there's not much, there isn't much that that you need to do, really. There aren't that many components here. You know, you got some biasing resistors and some capacitors. Because the capacitors are mostly ceramics and they tend to hold out quite well, there isn't really much to swap out. Well, I think there isn't much to swap out. So far, all I've done is the audio amp and the power supply, and I'm ready to test that, which is what I want to do next, and check some voltages. The other thing I've noticed is that this thing's got a strange way of feeding a signal in here. That thing over there, I mistakenly identified as the AM antenna socket. It's not. It's actually an output from the preamp stage just prior to the volume control. That is an audio output. Now, that's pretty convenient because if it's an audio output, it's also an audio input. You can feed a signal into there and that'll be amplified. That is assuming you've got nothing coming in from your radio channels from FM or AM, because otherwise you'd mix the two. But that's going to serve to feed a signal into it, and we can check what the result is and how the output stage, the audio stage is. But yeah, that's where we've got so far, and so far it's been pretty pleasant. So let's take a look at what's been done so far. Everything that's green has been checked. Obviously it's got mostly to do with checking that the B+, the voltage supply, gets to where it's supposed to. So I just follow the lines where they go, measure the resistances between the supply and the respective points. If it's green, it means that it's checked out okay. Over here, we have that resistor there that proved to be a little bit out of spec, and it was looking a little bit tarnished, a little bit melted, so I swapped it out. I haven't tested the voltages. You start noticing some slight differences in this radio compared to some of the ones that I'm used to. For example, this speaker just floats. There's no connection to ground. And I suppose it makes sense. I mean, why do you need it? They don't need it, they don't put it in. This is the Peter Ram's philosophy, less is more. I'm not sure that that they haven't cut corners, but we'll find out when we get this thing working. This capacitor is a ceramic. You've got the EL84 without a bypass cap on the cathode. It's 150 ohms. That measured fine. When I say fine, it measured 160. So it's about, 7% or whatever it is over, but that's within spec. That 1K came out at 1.1 or so 10%. These are 20% resistors, so this is fine. That one actually measured spot on, 1 meg. That was one of those paper caps or tar, whatever you want to call them, just about breaking apart, crumbling up, completely gone. So that was replaced. The rest, resistors, that resistor there, that capacitor there was also replaced. There was also a paper cap, and again, crumbling like crazy. And here you see this mysterious plug. You see, what we've got here is the switch between medium wave and FM. There's M, there's U. So you switch between FM and medium wave, and the resulting audio signal comes down here through that 4.7 microfarad cap, which I haven't seen yet. And it comes here to the top of the volume control. Now this volume control is just that. It's a potentiometer. No big deal. There is no tone compensation, loudness compensation circuitry, no feedback from the transformer and all that jazz that you normally see with these radios. It is a simple potential divider volume control. And here you have this section, this socket with the ground one as well, and it actually says AUS. It doesn't say it on this schematic, but it says it on the other one. There's AUS and something. I think it's like preamp out. I presume you could take this to the input of a tape deck and record it. That's what you wanted. And I know that they used to do that, and I know that Braun had some pretty good tape decks, reel-to-reel tape recorders. So that signal comes in there, goes through there, and goes to the preamplifier stage, which is the triode section of this tube. This is the EABC 80. It's biased with a 10 meg to ground. In other words, the cathode is straight to ground and there's a 10 meg from the grid. That is sort of a self-bias arrangement. You don't need a cathode bias. So that gets amplified, goes through there, It's fed B plus wise from this line here. This is the B2 plus line down here. So it's fed through that 200K resistor, and the audio signal comes out here. Now the audio signal comes out here, goes through that 3.3 nanofarad capacitor, which in the other one was 2.5, by the way. And then it goes to the grid of the EL84 with a ground reference of 1 meg down here. That guy there. Goes through a grid stopper of 1K. So nothing unusual, absolutely nothing unusual here. And it gets amplified, and of course it acts on the transformer primary, which is fed from the first B+. Here you've got that capacitor to ground, 2.5 nanofarads. That's probably just to roll off some of the high frequencies so you don't get any RF coming out of there. And it does roll off probably at a frequency well above the audio range. Stops oscillations and everything else, but it doesn't affect the audio, or it shouldn't. And then the way you work the tone on this thing is before the audio comes into the amplification stage, you have that capacitor in series with a variable resistor, and all you're doing here is you are leaking off varying degrees of high frequencies to ground. So if you make this maximum, in other words, you're basically shorting this out. If you send the wiper to the top there, there's no resistance. So that capacitor is directly connected to ground. And if you have a capacitor, 5 nanofarad capacitor connected to ground from an audio source, it's going to take a hell of a lot of the high frequencies and just dump them to ground. So they won't even get to the grid to be amplified. As you make this value larger, in other words, as you unwind the spot, let's say you put it at the minimum position, you've got 500 kilo ohms in series with that resistor, you're creating a frequency shelf. In other words, you're changing the position, the frequencies at which this path becomes accessible. So less and less high frequencies come down and short to ground. Therefore, more and more high frequencies can get into this point and get amplified. So that's all I have for the tone control. And that works perfectly well. It's just basically a treble cut. Nothing else. When I talk about minimalistic, this is as minimalistic as you're going to get. Now, this is all there is to the power amplifier. 1 preamp triode. This tube has got, so this is a triple diode triode. But for this particular function, this audio function, all we're using is this triode, which is effectively independent of the other 3 functions within that tube, which are 3 diodes. There's one, there's the other one connected. That's the anode and cathode. That is the anode and cathode. So these 2 diodes share a cathode, which shares the cathode with this particular triode. No big mystery there. And that's our audio circuit. So if we feed a signal in here, provided we've got nothing coming in from that end, we should hear that signal coming out of the amplifier. And that's exactly what we're going to try now. I'm going to feed in a 1 kilohertz sine wave and see if we can hear it. And then perhaps even look at it on the scope, see what it looks like. All right, let me get on with that. So what have we got? We've got a 50 millivolts RMS sine wave at 1 kilohertz. That's been prepared to go into the input. I've connected it directly to the input there, which is actually an output. There's our switch and volume control. This thing doesn't matter. This is the AM FM selector, but there's no FM tube and there are no IF amplifiers in there. So we still don't know whether that's working. What else have we got? And why don't I hear anything? Why don't I? Oh, yeah, good reason. Volume's at 0. Bloody hell. Okay, I had the signal generator not active. Let's put it on. And we've got signal. We've got a sine wave. And it's actually bloody loud. Yep, it is pretty loud. So, the audio is working, and there was not much that could be wrong with it except maybe the tubes. So, just to let you know, I had powered this up without the audio tubes. Once I reformed this capacitor, I did power it up just to check that the voltages were getting to where they're supposed to be getting. I had that thing on maximum limit as well, just so that we don't get high voltages. Nothing sparked, but I hadn't tested the audio yet. So the two audio tubes are fine, the power tube and the preamp, which is good news. Yeah. What I'm going to do is do some voltage checks while we're at it. Let me put the volume down and see what voltages we're getting. We should get, according to the schematics, we should get 175 volts. Connect that guy to ground. Put that thing on volts, DC volts. This is Big Brother we're going to use. And let's have a look at the B+. But I've got maximum limit on there. That won't tell me much, will it? Let me connect this a little bit more permanently so that we can get a hands-free approach on here. I'm going to connect that to the output of the selenium diode. So that's connected. That's B+ you're looking at now. What are we getting AC wise? Not much. Well, 2.5 volts AC. That's not bad at B+. So now I'm going to increase the current flow through there. In other words, I'm going to reduce the limit by giving it more light bulbs. See what happens. 160. Let me give it another one. 165. Well, it's close enough. I'm going to actually bypass the dim bulb limiter. 168. That's pretty close. That's pretty close. Let me put that back on. So I've got close to the voltage that I'm supposed to have there. I'm supposed to have 175. That is pretty close. So maybe, just maybe, that diode is fine. Of course, this is not drawing all the current that it should because A, there's no volume. I mean, I can put it on there. It'll increase the current draw a little bit, but the other tubes are not in. The FM tube isn't in, and the two EF89s are not in. So I'll only be able to really determine just how much voltage drop I've got across that selenium diode once I have the full current draw. So for now I'm going to leave that, and for now I'm going to proclaim myself fairly happy with this. It is a little bit low. I'm going to bypass it again just to see if it goes to 175. It is a little bit low, but not much. Let's see what B2 is. B2 is supposed to be, what is it supposed to be? According to the schematic, it's 175 on the one side and 150 over here. $165. Yeah, it would be, wouldn't it? Because the other tubes, the three tubes that are out, in other words, the FM tube and the two other tubes, the EF89s, draw current through that 1K resistor and would make this voltage go down. So I can't really decide anything from this data, but that's fine. What I wanted to know, I have discovered, and that is that it's working. It's working. Now what I'm going to do is I'm going to replace that speaker with a dummy load so we can see it on the scope and see what kind of signal we're getting out and what kind of amplitude that signal has. In other words, what kind of power we're getting from this thing. I wouldn't expect it to be too much. This is a small set. But let me do that. I'll just rearrange this so we can get a dummy load in here. I'll have to desolder the speaker, connect a dummy load, and then see it on the scope. Right, here we are. I've got the speaker connected into the dummy load selector. That's the one I did in the last project, redid in the last project of mine. Speaker in. I've got speaker selected. I have 8 ohms for dummy load. When I put it on dummy load, it's set for 8 ohms at the moment. And I've got the signal coming into the scope. I've got to make sure this is ×1, and it is. So let's put the volume up and see what happens. Nice. And I can hear it because it's on speaker. Hit dummy, and what do I get? 384 millivolts on speaker, 5. I think the speaker is more like 4 ohms, closer than 8 ohms, because the actual amplitude I'm getting there is 383, and on dummy it's 529, which means that it's not an 8 ohm speaker, and it's not a 4 ohm speaker. It's probably halfway between, which is the normal thing with these things, 5, 6 ohms. But we'll leave it on 8 ohms, see what happens. And now I can up the volume, see how far we go. Oh dear, starting to curve at the top there. That's maximum volume. Let me increase the amplitude of the test signal to 100 millivolts. You can see what happens there. So with an 8 ohm load, I've got 1.9 volts. But I do have limit on, so I'm going to bypass the limit. It should give us just a bit more. Not much. 1.94 volts RMS. Let me put it on 4 ohms. See what happens now. 1.7 volts. It's fairly clean. At least there it is. But it does start clipping at the top first. We try the tone control. Yeah, I've got the tone control on minimum, which means it's cutting down high frequencies. And if I put it up, it's cutting less high frequencies. In other words, it's allowing more of the 1 kilohertz sine wave to go through it. So once 1.75, 1.74. Not much, is it? Could be a weak EL84. It could be the bias of the EL84 that's not optimum. So, I mean, this clipping has got probably purely to do with the power tube, I would think. Could also be the preamp, the triode. But that's something I'm going to look into. I'm going to see what happens when I change some of those resistors, because that 150 ohm cathode resistor on the power tube was a little bit high. I'm not sure that they actually tell you what voltage. Are you supposed to have 4 volts on there? 4 volts. 4 volts on the cathode of the EL84. I'm not sure that that's much. If I'm not mistaken, the sort of normal is more like 6. So that could have a lot to do with it. But that's how they chose it to be. That's what it's supposed to be. So this thing obviously has a pretty low power output. Not that it sounds that way. I mean, that's pretty noisy on speaker. Let's see if we can get it to clip. Yeah, 1.9. Ohms. Okay, well, we've got some progress. What have we got? We've got the power supply working. The output voltage is a little bit low. The B plus is a little bit low, which means that selenium diode is probably dropping too much voltage, which means we may have to bypass it with a silicon diode, in which case we're going to have to drop a few volts, because usually it'll end up being too high. In other words, the AC coming in is being rectified by one diode, and that diode has a voltage drop. If it's a silicon diode, it'll be 0.6 or 0.7 volts. If it's a selenium diode, it could be 20, 30 volts, depending on what state that diode is in. So I might have to change that to a silicon diode, but then it means that part of the voltage drop that the circuit counted on is no longer there, which means that the B plus will be too high. So I have to put a resistor in series just to drop that a little bit. Don't know how much yet, but we'll see. I think that's it for this video. I've got to remind you, a lot of these things that I do here, I'm not going into in a lot of detail because I've done these little building blocks. I call them restoration building blocks, where I have various videos that show in detail how I test the power transformer, how I test the output transformer, how I change out selenium rectifier for diodes, how I restuff capacitors, how I do the reforming of capacitors. So all those are in separate videos which you can go look for. Just look for building blocks in one of the playlists on my channel. It's called Restoration Building Blocks. Most of those videos are in there. The other thing that I've got is the previous radio restoration that I did was a, what is it? Jesus, SCHAUB-LORENZ? Was it the LOEWE-OPTA? I've got it looking at me now. It's the Rheinperl, the LOEWE-OPTA Rheinperl 5171, I think it was. And I did that in incredible detail. There's about 9 or 10 videos on that one. And I did that on purpose to go into a lot of detail about how I do some of these things, so that I wouldn't have to repeat video footage on every restoration that I do. And the reason I did that is I keep remembering when I was sort of learning about tube radios and their restoration, is I'd go and watch some guys on the web, on YouTube, who had some pretty good videos, and they would sort of jump over things that well, honestly annoyed me because I didn't know what they were talking about. And I had to go back to some of their previous videos in their collection to understand what it was they were doing. I wanted to avoid that, so I made the Building Blocks channel playlist precisely for that. Because when you do something like this for long enough, you have to remember that not everybody is looking at it and understanding what you understand. Some people are still learning about it. Some people are just refreshing some of the electronics knowledge. This is a different field of electronics. As I've said before, when I finished university in 85, I think it was, yeah, we didn't touch tubes. I mean, tubes were gone. They were the past. We were into chips and transistors were actually almost part of the past. We were into integrated circuits and everything else. So I had to sort of go back and learn part of the electronics field that I had skipped over or not done at all. And I'm sure a lot of people out there are doing the same thing. So anyway, that's it for now. I'll be back soon with the next video. I hope you've enjoyed that. I certainly have. And if you do enjoy that, please click like, subscribe, share, and all that jazz. And if you want to support the channel, you can do so on Patreon. Thanks for watching. Bye for now.